So we always explain things in the world with math and chemicals, but that's not all true. And I got 4 reasons why. Now, I created a paradox called the rock, paper, scissors paradox. That's my first reason. The odds of winning is 1 in 3, the odds of losing is 1 in 3, and the odds of a tie is 1 in 3. Now, let's say that 2 people, they're like, hey, let's play a game of rock, paper, scissors. But if there's a tie, then they have to repeat the game. And the question is, what is the odds that A would win? Now, everyone, they're like, I know it's the outcome is only A winning or B winning. And since they're equal, then the chances is 50-50. But when you explain this with math, it's not actually true. Here is a pie chart I created. A represents the blue, B represents the red, and tie represents the yellow. They all have a 33.33333 chance of either one. But as you can see, there's a tie, and obviously a tie, they shouldn't end in a tie. It should repeat. So what do? You replace that, and a third of that piece there would be a third of that piece. So we would split those into thirds. Now A2 represents A winning, but in round 2, and B2 represents B winning in round 2. And you can see A's chance of winning is 44.444, pretty good. But obviously you could tell that there's still a tie. So we replace that with A winning, B winning, and C winning. And the chances of winning is 48.148148. But you could still see in the little yellow area, there's still a chance. There's a 3.7 chance. So we got to replace that tie with A winning, B winning, and a tie. Even though you have a 49.3827 whatever chance of winning, you could still see in the middle there's still a tie. So what's going on there? So I created an equation. This is the equation for the chances of tie winning. X is the number of rounds before you give up, and Y represents the chances of a tie. 0 rounds would obviously have a 100% tie. No one would win because we wouldn't play. And the chances in 1 round, it's 33.333. But the equation says 100 divided by 3 to the power of x. So if we want a tie to have a 0% chance, then we would have 100 divided by 3 to the power of x equals 0. But that also can equal 3 to the power x equals 100 divided by 0. And if you know about this, 100 divided by 0 is impossible and probably will blow up the entire universe. Now, logic says that the chances of A winning is 50%. Seems legit. But if you explain this in math, you know it's just roughly. It's not exact. You can't have a round where it's a 0% chance of a tie. And this is like the game of roulette, you know, the one where you spin the marble and it lands on a color. Even though there could be like a round, like a game where there's 10 times where it lands on red in a row, but still the next game, the chances of rolling a red is still 50-50. Now, the second reason is golf. Now, I created 2 people. The one in blue is math. He trusts more mathematically and scientifically. And the other one, they trust logic. They trust their gut. They trust their brain. So they both work at a mini golf place. Can't think of a name, so I'm just going to call them mini golf. And, you know, math obviously is good at math, so it works the cash register, and then logic works sweeping the area. And the manager comes, they're like, hey, let's have a meeting, and we're going to have a sale. And that sale is that for each family, half of those kids get it free. Now, an average day person who's just lazy and just wants to get everything done, he's like, how about this? Let's just get the average number of kids per family and then split it in half, and then those kids would get it free. So they grab the average number of kids per family in the town, and they got 2.5 kids per family. Now, some of you, that's like, doesn't make sense, but for those who think, that makes sense, this is what 2.5 kids look like. And I think one kid's pretty unhappy, maybe they're happy, but don't worry, they'll grow up to be 2.5 men. They have their own show. But there's still one more problem. That's just the number of kids per family. Now you can split that in half. So 1.25 kids get tickets for free. Now all of you laughing, you're probably happy, but the manager isn't it. So in the end, logic's like, why don't we just, for every kid, they have 50% off. It makes sense. No matter how many kids you get, you always get the price divided by 2. Now, what this explains is that fractions don't really help in some objects. You can have 2 kids each and 3 objects, but when shared evenly, you can split candy but not a toy car. And I got a third reason. So in math class, we're learning about parabolas, and this is a parabola mostly explains about how throwing an object. And for each number, they can be explained. So -16 is gravity, 10 is the force, and 4 is the starting height. But then there's other factors. This may look legitimate, but there's also wind. Maybe the wind would affect throwing a piece of paper. It depends on if you're throwing it left or right. Maybe it's spinning. Maybe spinning would affect where it lands. Maybe when I'm throwing something, the weight is on one side rather than the other. Or maybe the fact that you can't really go through the floor or go backwards. Now, the third reason is, what is love? Now, out of everyone I know, and just me, I know there's 3 different types of answers. The first one is the brain, talking about scientifically. You know, there's a chemical in your brain that hits the emotion part and makes you do stuff. But like really, we can't know what love is just by telling what you think in your brain is. We go like, there's something that interests us, like a thing or object or a person, that we would be disappointed or depressed without. Third response you can get is, baby, don't hurt me no more. Now, technically, all these answers are correct, but they have different meanings in them. One explains scientifically what goes on in the brain. The other one, that's like, we know what love is. We could say, look to your left, look to your right, those people you probably love or something. And the third one is a 90s reference. Now, there's a final one. It's called robots. So there's this video I won't get into, and it talks about like how robots learn, how they can tell what you mostly like so they can have recommendations in your social media. Self-driving cars, they could tell the difference between the road and kids. But there's a complicated reason for it. So imagine a robot telling the difference between 3s and Bs. Now, everyone, I hope, can tell the difference between a 3 and a B. Mostly young people, too. But explaining this to a robot is very complicated. You can give them details about what they look like, but robots don't really know words or objects. They just know codes. So it just goes through this complicated thing of just each robot gets like a random code, and then you put them in this test, and then the highest people get copied, but with small changes, while the other ones are thrown into the fire. And even when you get a robot that can tell the difference between 3s and Bs, they can't really tell an upside-down picture or a video or things that clearly aren't Bs, but they might say it is. Now, what I'm trying to say is that the world is too complicated to explain with numbers or equations or symbols or just rules itself. It's not a bad thing, but it makes us in a good way. It makes us smile in a good way. For example, it might be difficult for robots to replace certain jobs. And then you also get the thought, maybe we're not living in a simulation. Robots can be like confused, malfunction, don't even know what you're saying. Have you ever tried talking to Siri and she understands you? So math doesn't really equal logic. Thank you.